How's that? Still kind of an echo. All right, so we're going to talk about keeping smoke controls systems maintained and active. So some of your learning objectives here, obviously, we want to do a high-level overview of what smoke control systems are, understand why they're required, where they're installed. We'll learn some of the codes that drive the inspection, testing, and maintenance. So what do you need to be doing and why? And then we'll look at how project upgrades or tenant improvements cause problems for smoke control systems. And that's probably the biggest one that I get called in to help fix later. And then we'll learn some frequencies for the significant ITM stuff. All right, who am I? So my name is Scott Golly. I am local to here. I'm with Jensen Hughes. Our headquarters is right down the street. I have business cards and some flyers up here if anybody needs any. So we're largely a fire protection design, life safety consulting firm. We do a little security and stuff too. We're pretty global. I am currently vice president, and I am fire and building safety service line leader for special hazards. So really, smoke control is not my jam anymore. I've done a lot of smoke control most of my career, largely for air traffic control towers. I've been with Jensen Hughes for well over 20 years, coming up on 23 years, and I've been in the industry for almost 30 years at this point. I also like to point out I'm a volunteer firefighter, and the biggest reason I always bring that one up is I've been in Harford County and Baltimore County, currently in Harford County. Been a firefighter for over 33 years at this point. I think it gives me a different perspective when I look at these systems, when I look at anything fire protection related, because I see how the responders deal with it as well. So I try to apply that knowledge to my designs. Most of my technical focus has been large-scale fire alarm and mass notification systems. So if you have any questions on that, I can certainly help you there as well. Special hazards fire protection systems. The biggest thing keeping me busy right now is a lot of the AFFF replacements, PFAS-based fire suppression systems. But I do a lot of water mist and unique data center type fire suppression. Lithium-ion batteries are keeping me busy right now. And then I do just general fire protection system design. So I'm a systems designer person. I am a nerd by self-proclaimed definition. I love the systems, the model numbers of parts and widgets and gadgets. So if you have questions there, I can probably help you with that. All the legal stuff, this is all the pictures are copyrighted. The presentation is copyrighted. It's for educational purposes, all that stuff. We won't have to read that. So why is smoke control required? And why is the ITM important? So you've probably heard this 1,000 times, but we'll reiterate it. Most fire deaths are caused by smoke inhalation, not physical burns or fire. Often smoke incapacitates, so quickly people are overcome and cannot make it out of a building. So obviously, most of what we do now, you see the exit signs everywhere. All of that is related to the smoke component of fire and trying to help people find exits and get out of a building. Smoke control is typically provided to limit smoke spread, right? We're trying to control where it is and we're trying to keep it away from the means of egress, and that's probably the biggest component to it. Unfortunately, a lot of requirements are the result of lessons learned, and we'll talk about some examples of that. The fire protection industry is one where we learn really hard lessons that are almost always life loss based. From little fires in theaters to things like the World Trade Center, which basically rewrote a lot of our codes. During the life of a building, maintenance is essential. Changes in the building and maintenance of the systems is, this is one of those systems, we don't need it till we need it. So it gets forgotten about. And smoke control is one that very commonly, we will go in to do a renovation, we'll get pulled in. Previous renovations didn't have experts on it, so we'll get pulled in to help with a new project and find out that, you had a smoke control system here and you've disabled it like 10 years ago. So a lot of our job is trying to figure out what happened to the system and why it doesn't work. Is the audio okay? Because it sounds very echoey to me, but okay, I'll try not to talk as loud. So the research into the smoke control began right after the 1881 Ring Theater fire. So it was a fire in Europe. Not a significant large life loss. I believe there were 9 lives in that one. And it resulted in, they used to use the old flame-based projector systems to light the stages and things. And they lit one, and due to a buildup of gas, they lit all the screens on fire and ended up having 9 lives lost. The first successful use of smoke control was in 1911 in the Empire Palace Theater in Edinburgh. I don't know if it was fully successful. It actually had some challenges associated with it as well. And then the 1980 MGM Grand. So that's the big one in the US that really drove our industry to to really change the code and make the US realize smoke control is a necessity. That's fantastic, thank you. So what happened there, 85 people lost their lives. 65 of those people were on the 20th floor and up. The fires were on the lower levels. So smoke got pushed throughout the building and people lost their lives because they couldn't get to exits. That drove a lot of US code and has been a big driver ever since. So a lot of these, there's probably 100 examples like this where we get taught these in fire protection engineering. And they still teach these in fire protection engineering to drive the meaning of why we're doing this. All right, so where is smoke control required? The biggest one is probably high-rise buildings. So high-rise buildings, we have, a high-rise is typically defined, and I say typically, some jurisdictions do define this slightly differently. Most of them define it as 75 feet from the lowest level of fire department access to the highest occupied floor. So a large number of buildings, anything over 7 stories-ish, you're probably into high-rise, right? So if you have a building in that area, you probably have some type of smoke control, from basic to pretty complex. And I'll give you examples. And if you have specific questions, feel free to reach out to me afterwards and we can talk about your example. But some of the obvious ones, every interior exit stairway that goes from 75 feet down has to be a smoke-proof enclosure and it has to be protected by mechanical means likely. So likely you have what's called stairwell pressurization. Very commonly I see it not working. So if you ever have stairwells and you see smoke detectors outside of your stairwells, those are mandated. And the job of those smoke detectors is to activate, obviously, the fire alarm, but also that stairwell pressurization system. Floor-to-floor smoke control, we'll talk about those later. And all of these we're going to go into a lot more detail on. And with a smaller group like this, I never mind answering questions. I did only practice this from the beginning, so I have to start over, but I certainly don't mind questions. No, I'm kidding. Fire away. This is a nice group to have conversational discussions. So, and then, the smoke removal for post-fire, that's probably the most prevalent now in most jurisdictions. When the fire department gets there, how can they get rid of the smoke and do salvage and overhaul? And then elevator hoistways. So there are 2 options in the fire protection architectural world. You can either enclose the lobbies of your elevators and not provide sterile pressurization, or you can, elevator shaft pressurization. You can either enclose the lobbies or you can pressurize the elevator shaft. And we'll talk about why that's important and what it does in a minute. Atriums, probably the second biggest application of where we're going to see smoke control. Anytime you have, and again, this definition varies a little bit too, but any vertical space that's open that connects 3 or more floors. Some jurisdictions do 2 or more. For the most part, it's 3 or more. And then, you see here, if it's a institutional occupancy, you're likely 2 or more floors. Obviously, why the difference? Well, we may have people that can't self-evacuate. All right, so atrium smoke control systems are typically built off exhaust-based solutions and have a whole lot of complexity to them that you may not be thinking about. So we'll talk about this one in detail, but usually there's an exhaust fan at the top, and then we have makeup air somehow, right? If you pull out too much air, you get a negative differential in the building, but you're probably just pulling air from everywhere. So likely there are doors that automatically open, louvers that automatically open, supply fans that come on in lower levels and help air come in the bottom, and we pull it out the top. Objective being we're trying to keep that smoke layer above the top level and above occupants, and we'll talk about that more in a minute. Some other examples, and I won't read all of these. Covered malls, pretty common. Underground buildings, if it's 30 feet or more below grade and it's occupied. So does that mean a car park will have smoke control? Possibly, if there are occupied levels married to that parking in the lower levels, but there's also exhaust requirements for parking garages, so that you may have 2 different types of systems there. Road tunnels, that one's common. We're doing a lot of detection and suppression type solutions in tunnels now worldwide. Institutional, we already talked about a little bit. Stages and assembly areas. And stages are tough to work with. There's a lot of complexity when you get into really tall stages over a stage. How do I activate it if smoke doesn't make it up to the smoke detectors? Do I need to do creative detection solutions? I was dealing with that one yesterday. Fixed guideway transit, so passenger rail systems, amusement buildings. So this one is very common. Big theme parks, even if it's not required to be there, if they're low light or limited egress or a challenging environment where there's a lot of special effects, they may mandate smoke control anyway, right? Even if it's not a code requirement, it's kind of above and beyond. If they're using theatrical smokes, if you are intentionally kept in the dark for whatever reason, right? It's excitement factor or whatever, often smoke control is required. And that can be by state to state and by theme park to theme park. Like Disney has their own code requirements for about everything they do. Air traffic control towers. So air traffic control towers, I've spent a large percentage of my career running up and down the East Coast and out to the Midwest looking at air traffic control towers. The biggest challenge there is a lot of those towers were built with a single means of egress. So we want to make sure that means of egress is a safe means of egress no matter what the challenge. And some of those towers, 300 to 350 feet in the air. So it's a big challenge. And then alternate means and methods, right? Trying to accomplish something that isn't really allowed in the code, we could add smoke control as a trade-off. All right, so let's talk about what the different methods are. And this is where you might see, oh wait, maybe I do have that in my building. So the exhaust method, I briefly talked about that with atriums. We bring in the supply air down low, and we pull that smoke out at the top, and the objective is to keep that 6 feet above the top occupied floor. It would be more than adequate for me. For some of you, you might be head in the smoke, but for me, I'm way under that. So that's the objective, right? We're looking to keep the smoke out of the occupants' faces and leave it a tenable environment so they can get out of the building. All right, so airflow method. So these are an example of this, and really similar to an atrium, right? But the airflow method would be, an example would be BWI Airport. Did anybody fly in by chance? Or I assume you've all been through BWI too, right? So you have different spaces, concourse A, B, C, the terminal building, all that stuff, right? There's no physical barriers to a lot of those spaces, but I have to keep the smoke out of one from getting into the other. The way we do that is force mechanical airflow and force the air to where the fire is, and then it pulls it out over the top of it, so the smoke doesn't spread throughout the building. That's the airflow method in a nutshell. All right, the pressurization method. Legacy, this was very, very common. It's not as common in the automatic world anymore. California, it's still pretty common. It's also been called sandwich pressurization. So the idea would be, if I have a fire on this floor here, I negatively pressurize that, so all my air handlers go to a negative exhaust mode, and the floor above and the floor below go to a positive pressure mode. The idea being, force that smoke to stay right there. Then I turn on the stairwell pressurization systems and I keep it out of my stairwells. That's the idea. You can tell really quickly though, if the mechanical systems are evolving and the contractor working on the mechanical system doesn't do fire protection for a living, they may lose that sequence of operations. And that's the most common thing we see fail in these and atrium systems and high-rises is over the years, facility managers didn't understand that fire protection is there, right? So we would like for facility managers to be fire protection advocates. Understand that everything in your building may have dual purpose. And if you don't know, ask experts to come in and give you an assessment. Some of the older systems, they would just pressurize the floor above and floor below. This was pretty common too. So these two are probably the most common methods for really tall high-rises. You pressurize multiple floors above, multiple floor below, and then negatively pressurize the fire floor. The objective there being keep the fire on that floor, but evacuate all of those floors that are in the exhaust mode or in the smoke control mode. So on this example, I would evacuate all 3 of those floors. So it is common in high-rises not to evacuate the entire building necessarily, right? We do the fire floor, floor above, floor below. So it starts getting complex. Now to do that, right, we're not putting in a cheap fire alarm system that somebody bought from the local supply house. These are big fire alarm systems listed for this application. It's called a UUKL listing. And they are very complex. The sequence of operations is complicated. It trips lots of other systems. Sometimes they are directly integrated with building automation. I don't like those as much, but it can be done. So understanding the system you have in your building is pretty critical, and we'll talk about how you know what you have here in a little while. So pressurization method, we've talked about this a little bit, right? So I've got my stairwell here, I've got a fire here. Smoke detection goes off, or sprinkler, we get a sprinkler flow. Automatically, I turn on my fresh air source at the top. I say top, it's not always at the top, but we turn on that air source and we positively pressurize that stairwell. And when I say pressurize, we literally build a differential pressure between this stairwell and this building. And we have to measure that during commissioning. So depending on whether the building is sprinklered or not sprinklered, which most buildings are sprinklered now, right? It's possible you're in an older building that isn't, but unlikely now. So the sprinklers allow a slightly lower differential pressure because in theory we're keeping it to a smaller fire size, right? And that is historically shown to be a fact, right? Sprinklers keep fires very well contained likely. So we then test between this interface and this interface what that differential pressure is when this is on. That's part of the commissioning, and we'll talk about where that would be documented. Again, you know, there's some complicated sequence of operations here in the fire alarm. So we're not just putting in smoke detectors and making it go loud and just annoying people with audio, right? There's a sequence of operations. This input means this output, if-and statements, things like that. Depending on the system you have, it can be very complicated. So the commissioning is critical. All right, passive method. This one is probably pretty intuitive. The idea being, I don't do anything, but my doors are already closed. I've got smoke-proof enclosure doors in place. So if I have corridor doors, they're going to be maintained in the closed position. And then in a fire, hopefully that smoke stays contained, right? So I say hopefully. One of the biggest failure points to these is the little wooden triangles that you can jam under a door, right? Or IT. I can run IT through a wall. I don't need a precise hole. I need a hammer hole. So I just punch a big hole in a wall and run cable, right? So those are the biggest weaknesses to smoke control systems. We'll talk about tenant improvements and modifications and how that impacts the system in a minute. But you know, anytime you're doing a renovation, and it can be as simple as I'm adding a network drop, punching a hole in a wall needs to be thought about. If it's a corridor wall, that might be critical. Stairwell wall might be critical. So I may now be letting smoke or differential pressure air move in and out of a room that it was never intended to move in and out of. So you kind of got to think through all that is kind of the point here. Okay, so air changes can be used anywhere in a building. This is not as common, but basically I'm using forced supply air and exhaust air, and I am trying to dilute the smoke out of that space. I'm not a super big fan of this one because it can also feed your fire, but it is used. And again, lots of sequence of operations here, right? I've got inputs that turn all this on, and then I've got this fan, this fan, this fan. They all work differently based on the floor. There's a lot of complexity here. But this was common in the Uniform Building Code, which is a legacy older code that kind of predated the International Building Code. Was pretty common, and you used a cold smoke test to test for it. The way we would do that is you literally use a smoke bomb, and you put it in a heat generator, and you dump smoke, and then you turn on the air handling system, and you watch it dilute the smoke. And you can measure obscuration and all those things. Not a big fan of these systems, but if they're there, they need to be maintained and tested properly. So, and I've continually referred to it, but all this slide is saying is when you look at smoke control, you are looking at a whole bunch of pieces to a building solution. And it starts with the architect. The architect may have built in barriers that are required to be smoke-proof enclosures or smoke barriers. Mechanical, obviously I've got air handlers or dedicated equipment that's only job is to do smoke control. So if you've ever been walking around on the roof of your building and been like, what does that fan do? It's never turned on in its entire life. It could be this, right? Electrical systems. So one big challenge we're dealing with right now is a jurisdiction just came in and said, I need smoke control in this building. Their electrical cannot handle the load of all the air handlers kicking on at one time to go to an exhaust mode. So they want to stage the equipment on. I can't stage equipment on. There's a time requirement on how fast I have to be in a smoke control mode. So now they're looking at electrical upgrades. And then we may also be looking at standby power or backup power. You know, you may be looking at battery backups or generator backups because this stuff has to work in a fire. A lot of times one of the first things the fire department does is disable power to a room before they can fight fire in it. And then obviously fire protection, right? So, and we'll talk about how everybody's involved. The authority having jurisdiction. So I like to say this when a lot of building owners panic, but the AHJ, your authority having jurisdiction, your fire marshal, they should be your friend. They should be your ally. And often when I have a challenge with a client, I'll be like, let's ask the fire marshal, like, we don't want to bring them in here. I'm like, well, if you're that worried about bringing them in here, we probably have other things we need to be looking at and talking about. I shouldn't have concern about bringing them into your building, and I want them to be part of a solution that they and their firefighters like. So I'd rather have them help me develop a solution. Some jurisdictions don't want that, and they'll just say, we're glad you're a consultant? All right, just let us know how it goes. Sometimes that happens, and that's pretty common. But if you can, they should be part of the solution, because the complexity of commissioning these, they have to sign off on it. Okay, so what are the three major components to building a successful smoke control system? That first is the design. The design usually starts with fire protection engineers or mechanical or architects. Sometimes all three working together. But usually the fire protection engineers are the ones that go, that's a 3-story atrium. You need smoke control now. And the architects go, but we don't like smoke control. And then we end up in fights with architects. It happens a lot, actually. Nah, they're all good. But mechanical has to be involved, because the equipment has to be capable of doing it. And I'll give you an example. The old pneumatic systems, a lot of those pneumatic solenoids are not fast enough to comply with the requirements of smoke control systems. They open too slowly. And if I have pneumatic dampers in one area because those are legacy, and now we're putting in everything else as electric actuators, and then I kick all the air handlers on for an exhaust system, but my pneumatic opens too slowly, I can pull doors off frames, I can break windows, I can cause problems, I can collapse ductwork, right? So the whole system has to work together and in the time requirements that are necessary. So commissioning, I mentioned IBC earlier, but this is the big driver here, is International Building Code. That's probably the most commonly applied code everywhere. Unless you're in California, there's California Building Code. That gets a little complicated. But the International Building Code 9093 requires special inspections to verify proper commissioning. And that is actually, like, if you call my company or a consulting firm and you say, I need a special inspection for a smoke control system, we already know what that means. That in itself is a definition. Primary intent of the requirement is to independently confirm that everything works. That complicated sequence of operations I described, it gets really complicated on these systems, so we want to test every single piece. And then the maintenance. If you've got maintenance contractors coming in, and so one big reason I mentioned earlier, I don't like the building automation systems interacting with my fire alarm systems and the smoke control. The biggest reason is most technicians that work on big fire alarm systems, they know this, they understand this, and they get that their job is life safety. Mechanical contractors may or may not. They may be really phenomenal at putting in air handlers, but they may understand I got to balance my system, I need this much airflow, I need this much temperature, I got to run this much airflow to maintain that temperature. They're great at all that. But then if you go, okay, now I need you to shut that off, go into full exhaust mode, no supply, and they're like, we didn't design it for that. Well, that's because you weren't thinking the life safety piece. And when we start talking maintenance, they can make changes to balance a system that ruin a smoke control system. So all three are pretty critical pieces. All right, I'm not going to read through all of this, but this is kind of the meat and potatoes of what the code requirement requires. So the International Building Code, there are variations. You could have IBC, you could have the California Building Code, you could still be in UBC. If you're a government facility, you might be Unified Facilities Criteria, which largely adopts IBC and the NFPA codes. Government facilities get a little more complicated, so that's probably a separate conversation. The test report is filed with the fire code official and maintained in the building. So I said earlier, how do you know if you have one of these systems? You should have documentation on it. And it should be a pretty clear thing. There should be a test report that it was tested. There should be, you have to, if you have smoke control and it's designed into the building design, you have to have that system fully tested and commissioned before you can get TCO or CO, or occupancy. And then there is the report is required to be maintained in the fire control room or the fire command center. So what if I don't have a fire command center? Sometimes, older buildings, we get remodels. There's no fire command center. Usually jurisdictions will let that slide. They'll say, okay, we don't need you, because a fire command center has to have a door to the exterior, has to be at street access, has to be fire department address side, all these requirements. Has to be a certain size. You may not be able to comply with that in an older building. You may already have all that exterior space committed, things like that. So you may not have a fire command center, but the fire department's aware of it. they probably have other areas designated that they'll use during their command and operations. That could be safety or security office, something of that sort. If you're not sure where this documentation is, it's worth digging for it when you get back. Make sure you understand what you have. Beginning in 2021, the IBC now requires NFPA 4 compliance. And NFPA 4 is a standard for integrated fire protection and life safety systems. So in other words, now when I'm testing, it's pretty common contractors be like, look, normally when we do this, it'll trip these 3 air handlers, but we're going to bypass that, and we'll just show you the sequence of operations. NFPA 4 says no. If you test this system and it interacts with these 3, we have to see those 3 activate. What that means is when you're doing NFPA 4 testing, you better have everybody involved. Like, has anybody been a part of fire alarm testing and you know that it's going to recall your elevators? You want the elevator contractor there, right? Flow and sprinkler systems to really trip a fire alarm. That's the right way to test a sprinkler flow. I got to flow water. I want a sprinkler contractor there because the fire alarm guy might go, oh, I know how to reset it if it doesn't, if we have any problems with the sprinkler. Let's not trust that. Let's get the sprinkler tech there. So NFPA 4 kind of pushes that logic. Test everything, test it all together, and have all the people that are relevant to the testing be there. Okay, International Fire Code. So we talked about the International Building Code. The Building Code is how a building is built, and it is usually the addition from the date at which the building was built and commissioned. So if your building was built in 2019, it's probably that code. The International Fire Code is the one that is enforceable by fire marshals. That one is usually latest and greatest, or at least something a little newer. In most areas, that is going to be the 2024 International Fire Code. This is retroactive in most jurisdictions, and this is the one that can get you in a lot of trouble, right? This is what fire marshals can hang their hats on. I'll be honest though, most of the building codes can come out when there's problems. But the fire code is the one that is enforceable. Smoke control systems are required to be tested in accordance with the manufacturer's literature and that initial design document, right? So I just said the manufacturer. Well, maybe now I need the manufacturer of the air handling equipment there, possibly, or I need the manufacturer of the fire alarm system there. If it says manufacturer of fire alarm, is it okay if I have a licensed vendor who is licensed to work on that system in lieu of the manufacturer? Sure, right? That's the same intent. Routine maintenance and operational testing program is required immediately after. So as soon as I commission my system, I need a plan for how I'm going to test it, and it has to be documented. And this is not something on the back of a piece of paper. This is a formal document that gets maintained with your system. There needs to be a written schedule for how I'm going to do that maintenance and operational testing, and all those records are required to be maintained. Testing is required to include all the equipment, right? All the fans, all the louvers. If it opens and closes doors and you have a really busy atrium, that can be challenging during the day. So maybe we're doing this off hours now. I'm working at one in DC that is 6 or 7 massive buildings that are connected. It's that share a large atrium, and it's all big single fire alarm network. That building almost always we're testing it at night because there's so much volume of flow through the atrium. I can't open and close doors, and even if I can, every time I'm measuring a differential pressure and somebody opens a door in a stairwell, my differential pressure changes, right? So I'm supposed to be taking measurements during some of this. You kind of got to control that flow. All right, so when we start looking at, there's dedicated, non-dedicated, and then components that are bypassed on weekly self-test. We'll talk dedicated and non-dedicated a little more as the presentation goes on, but it's kind of self-explanatory. If it's equipment that is only there for smoke control, sterile pressurization, right? Probably doesn't do anything else in your building except pressurize that stairwell. That would be dedicated equipment, and I'm testing that semi-annually, okay? Non-dedicated smoke control equipment, I'm testing annually. Why can I test it less frequently? It's also got a normal job. So if that air handler fails, I know that air handler failed because everybody's complaining it's now hot on the 7th floor, right? So that's why non-dedicated, the frequency is a little different. Components bypassed from the weekly self-test, I have to test semi-annually. So if I'm bypassing them during a weekly, these systems as part of the UUKL, they weekly look at all the actuators and they test it and they generate a report. If I have to bypass those because the main door's too busy, I can't do that one, then I have to test those specifically on a semi-annual basis. Does that make sense? Kind of blowing through that. All right. I talked about NFPA 4 before. We've talked through most of this, but integrated testing occurs upon the installation periodically and upon system modification. NFPA 4 as a code is relatively new in the National Fire Protection Association world. I probably should have said that before. Everybody knows NFPA is National Fire Protection Association. Okay. They're kind of they're the producer of most of the codes out there. And then there's the International Code Council, they produce IBC. So these are consensus codes. Any one of you could sit on these codes. You can help develop these codes. I've sat on NFPA 72 for 6 or 7 cycles as a consultant. So I've been part of NFPA 72 since before it was written. It looked totally different when I started. And now I sit on 1400, which is more of a fire department NFPA code. But you can be part of these. The periodic testing plan is required as part of the initial commissioning. So again, that's a fully documented procedure you're going to follow, and it gets maintained with the records. NFPA for 2021 edition, the testing plan is required for the 2026 because the periodic testing plan is required within a 5-year adoption of NFPA 4, right? So the owner is responsible for the system integrated, for selecting the integrated system testing team. So if you inherit a building as a facility manager and you're talking to the owner and going, I am having nothing but a nightmare of maintenance with this fire alarm contractor, you can change that as the owner. I would caution about doing it too much. It is often tempting to hunt for the cheapest inspection testing and maintenance contractor. There are negatives to that. If you are testing it for me this week and then next week you're testing it for me, do you want to own his work? I don't know. Maybe he's great, but I wouldn't. So I've dealt with customers that when I came in, they called me and said, we're having problems getting our system maintained. First thing I asked is, well, how long have they been maintaining your system? Oh, 6 months or so. I'm like, why only 6 months? Well, we changed it this year because they were a lot cheaper than the other guys. I'm like, well, maybe that's why they're cheaper, number one. And number two, how long were the other guys doing it? About a year. Who's doing it before that? Well, this other company. I'm like, so nobody wants to own your system. Nobody trusts that the last guy did it right. Nobody wants to come out for your emergency service calls because they see there's no loyalty. If they put their best people on the job and they do an amazing job, they're hoping you're going to keep them for multiple years. That is the best model in a world where we are maintaining a life safety system. They have the history with it, they understand your system, they know how it works. But there are scenarios where they just aren't responsive anymore. They got bought, right? We're in that world where somebody's constantly buying out another company. Maybe that ownership changed the responsiveness, and now you don't trust them anymore. So there are scenarios where you can change that contractor. You can pick that team. Just understand that team is testing life safety solutions that need to work right and may not be needed for 6 years, right? The integrated testing agent is a person or entity identified by the owner who plans, schedules, documents, coordinates, implements that test. That can be a Jensen Hughes type company. That can be you as the facility manager of your building, but you get to pick that and you have to maintain that person on record. Okay, NFPA 92. So very similar to NFPA 4, NFPA 92 is the standard for smoke control systems. That's where really the nuts and bolts of a smoke control system are designed from. Differential pressures, things of that sort, how air handlers have to work, the speed between the UL listings and NFPA 92. That's where a lot of that testing documentation comes from. Again, requirements are pretty similar. Testing is required semi-annually for dedicated systems, and then non-dedicated we get to go annually again. Same thing, right? The dedicated systems aren't getting exercised as much. Smoke control system is required to be maintained in accordance with the manufacturer's recommendation, right? Sounds the same. There's a correlating committee within NFPA that tries to make all the NFPA codes not contradict each other. It still happens, but it's very rare now. So this is one that's coordinated with NFPA 4. Okay, smoke control's not new. So if you're thinking, well, it's probably not in my building was built in 1989. Well, it was in the 1988 Unified Facilities or Uniform Fire Code. 94 it was out there, and it goes back further than that. So, and the inspection, testing, and maintenance requirements go back even further. So you likely still have it in an older building. Okay, I hate slides with a whole lot of text on them, so I'll try to paraphrase this for you. What is periodic testing? What periodic testing is required for smoke control systems, and what is the frequency? We talked a lot about that, right? Dedicated versus non-dedicated. Non-dedicated systems shall be tested annually, and the periodic testing requirements are airflow quantities and pressure differentials. Remember I said a stairwell pressurization system or an atrium system, there may be a differential pressure required across the threshold of the door. That needs to be tested. That needs to be tested as part of the periodic testing requirements. Testing of all smoke control equipment, initiating devices, the fans, the dampers, the controls, the windows, all of that stuff is considered part of the semi-annual or annual for non-dedicated. Backwards. Semi-annual for non-dedicated, or dedicated, annual for non-dedicated. Performed by someone thoroughly knowledgeable with the system. We talked about that already, right? This needs to be the people that understand your system, that hopefully have been a part of it for a while, or at least are very competent in their field. So I don't know that, you know, for my fire alarm system or my smoke control system, I'm hiring the small shop that's really cheap. Maybe this is the one that you're going with the big boy in the industry because they installed your system originally and they truly understand that sequence of operations. That sequence of operations can be a giant matrix and it gets really complicated. And then if you're in a government building and you add in mass communication or anti-terrorism requirements, now you get into different messages during different events and all sorts of stuff. So it can get even more complicated. Equipment shall also be maintained in accordance by the manufacturer's recommendations. So it is possible that the manufacturer of a certain solenoid relay component will require, oh, this one needs to be actuated or exercised every week as part of that self-test. That would all be in the rational report, that design of your smoke control system. So that's why that original documentation is pretty critical. Periodic testing is required to be conducted under standby power. So that may mean right there that you're doing this off hours, because you may have to drop power that inconveniences the rest of the building. So when we're doing full system testing, it is under battery backup or whatever the backup solution is. Okay, so how do I know if my system is current? All that basically says there's supposed to be documentation. There's supposed to be records of every test. There's supposed to be that original rational design document. All that is supposed to be maintained either in your fire command center or your security office, something of that sort. That's basically what all of that slide says. Your local authority having jurisdiction probably maintains records on it too. There are now automated cloud-based solutions that will do all this for you. Okay, so going back, you know, this is kind of the summary of you really need to understand whether your system is dedicated or non-dedicated. Advantages to non-dedicated is a lot of that system is getting exercised on a regular basis. The maintenance is going to naturally happen with every time you have belt problems. You're already calling the mechanical contractor. The louvers are being exercised when the mechanical contractor comes out. There's probably somebody more familiar with it because they're working on it pretty regularly in a large building. Disadvantages, it's constantly being exercised and I constantly have mechanical contractors working on it. So when I need it, it might not be programmed right anymore. Again, that's why I like a life safety contractor involved on the smoke control component for any of the maintenance. Dedicated systems, the sequence of operations is probably going to stay, but in the same respect, it's also not getting exercised. So I've definitely learned in my career there are two systems that get more attention than any life safety system, bar none. Internet, and is the building warm or cool enough, right? So those two are the highest priority to the tenants. Unless there's an emergency, then they care more. But unfortunately, that's the reality. So dedicated systems tend to get forgotten about. So the maintenance may not be there. Testing a dedicated system can be challenging. If it's stairwell pressurization, I gotta have all the doors closed because that's what I'm measuring my differential pressure against. So that's almost guaranteed off hours. Okay, what if a detailed design report isn't available? What if that original design documentation can't be found? You can contact firms like ours, doesn't have to be mine, but a consulting firm, they can come out, assess your building, look at what the code requirement is. I can walk into most buildings and with 5 minutes I can tell you, you need stairwell pressurization, your elevator lobbies need to be closed in. You know, like that's what we do every day. We are nerds. So you can have a company assess it. Your AHJ is probably maintaining a copy as well. So you can request that from, it's probably a plans and permitting office. You're probably not calling the fire marshal. So it's not as scary as calling the fire marshal. That report should live where the building's detailed design documents are. They should be together, because in more complex buildings, it had to have been designed with that building in the front end. And the operations and maintenance manual can also be provided for existing buildings by a firm like ours or a consulting firm that can come in and develop it for you. Okay, so this is probably the most relevant section here, and we've got probably about the perfect amount of time to go through it and then answer some questions. So what are the impacts of improvements in your building to a smoke control system? Even a minor tenant improvement, a floor rearrangement, can dramatically impact a smoke control system. Alterations, replacements, anything of the dedicated or non-dedicated equipment where you're changing it, that can dramatically impact it. Modifications to doors and windows. Like if I have a large atrium system or a sandwich pressurization system, remember those windows that were on a louver that automatically opened with an actuator, and you're like, why is there an actuator on this building? It was probably automatic, and it was probably makeup air for your smoke control. There are, if you have power doors in the lobbies, they can be part of the system where the system goes into smoke exhaust from the atrium and all the doors in the lobby automatically open. We get in fights a lot with security teams. They'll be like, no, you can't pull a pull station and have the doors open. Okay, but you can't occupy the building if we don't, because the smoke control won't be adequate without that makeup air. So maybe the answer is we build different louver systems in an existing building. That may not be an option. So often what happens is security will override the life safety. And then when you need it, the system doesn't work. So security we tend to get in a lot of fights with on things like that. There's usually solutions if everybody's talking. So the relocation of interior walls, that's the big one. Tenant changes, and I'll show you an example of how a couple of walls can make a system completely unfunctional. Opening stairs, convenience openings. Say you have a large high-rise, and I'll give you a great example. My company, we just occupied a high-rise down in Columbia, and we took 3 floors of that high-rise. And somebody's like, oh, we should have convenience stairs so we can just go up and down in our space. As soon as I open up the floors, could that impact my sandwich pressurization if I have it? Could that impact all the smoke control in general? Absolutely. Any modifications that trigger a change in the applicable building code. So a total occupancy change. Today it's a factory. This is a common one. Today it's a factory. Now we're going to do a revitalization of an industrial area in a city, and then tomorrow it's going to be residential buildings. That's huge, right? Like any of the big cities are doing that somewhere in the city. Baltimore's got a huge example of that. When I go from industrial to residential occupancy, all different stuff in the code applies. So that stuff needs to be looked at. All right, so let's look at a couple of case studies, and then we got time for some questions. Tenant improvement, we're adding a convenience stair interconnecting floors, okay? So these are your current floor levels right here, and I have a sandwich pressurization system, all sorts of complex integration of air handlers that go into supply or exhaust mode to give me positive or negative pressurization, and then I come in and so this is my current configuration right here, and then I come in and I put a giant convenience stair in there now. So now none of that system works anymore, and your smoke can readily spread throughout floors, right? So there are ways to deal with this. We can enclose it differently. We can do detection differently. So there are ways to deal with this, but it needs to be caught before the renovation occurs, right? And now your smoke zone just went from that to this. We can probably still work with it, but we need to know earlier in the design process. This one, interior walls, this is probably the most common. So this is my stair right here. Let's say it's a over 75-foot tall high-rise building that has stairwell pressurization in it. I decide I want to take this out, and this is going to be an open office area now. We'll put cubicles there. And we're doing this all over the place on a regular basis. Okay, so the original design, this section here is part of my means of egress. So I have to pressurize that with my stairwell pressurization system. So now I have to measure, I put the system into alarm, I have to measure differential pressure from here to here and here to here. So these 2 spaces and these 2 spaces. So the red and green and the green to gray. Now I do this, I guarantee you my fans can't do that anymore, right? So I just change the volume I have to provide pressurization for. Had that been coordinated with an architect or a fire protection engineer in the front end, you could have dealt with that with some simple enclosures and keeping some of the walls, not moving all of them. So when you're looking at a renovation, try to look at the big picture of, again, be that advocate for fire protection. Do I need to look at other systems I may be impacting here? Pneumatic to digital controls, pretty common as well. So damper controls upgrade. This one's probably not as common anymore. 10, 15 years ago, this was really common. You know, the pneumatic controls were pretty antiquated. Now I would imagine most buildings have probably already gone over to that, but a lot of non-dedicated equipment. It's shared, so my air handlers may be running on pneumatics, but they may also be doing double duty. We upgrade the dampers and all the controls to digital direct control. Along with the upgrades, we go to all PLCs. The impact of smoke control was not evaluated, pretty common scenario. The building was provided with an active floor smoke control system, and the exhaust on the floor / zone of alarm and supply on the floor and the zone of alarm above and below requires reevaluation completely, and now I may no longer have my zones at all anymore because the system wasn't considered for that. So that's the big one. Most of the good mechanical contractors that work in high rises, they're aware of these systems. And if you're not sure they're super comfortable answering the question of do you need it anymore, companies like mine can come in and pretty quickly say, oh, we can find a way around it with code, so you may not need it anymore. Likely you're probably going to need it, and we can explain what the boundaries are and things like that, and we can look at that rational analysis for you. Atrium fuel loads. We just dealt with this one recently. Atriums typically utilize the exhaust method. We talked about that, and there may be makeup doors down here that open, louvers, windows that are all part of this system. And when that system is designed as part of that rational analysis, we look at what you want to put in your lobby. There's going to be a Starbucks in the middle and a kiosk. We'll look at, okay, we want to use this type of furniture. So we're going to look at these types of furniture. Okay, it's all metal with an aluminum benching on it. It looks pretty, it's kind of Art Deco and modern, right? No fire load for me. So from a fire protection engineering standpoint, I'm like, ooh, I like that furniture. But the Starbucks is, you know, a X megawatt or X kilowatt fire. That all goes into the design analysis, and that helps us come up with how much airflow we need. So if you change that and go, ooh, now we want to go to polystyrene-based squishy couches, your fire load just dramatically went up. If you look at how long firefighters had for room and content fires in houses 40 years ago versus now, and then you start looking at lithium-ion batteries, like you see 8 minutes to room flashover, 3 minutes to room flashover, and then like seconds when you start adding in batteries, right? So as furniture has gotten more flammable, it creates bigger challenges. So if you want to change that furniture or that fire load in there, maybe big art wooden thing or things like that, that all needs to be assessed as part of it. And those are things that often we don't even think about, right? Like, it's our building, I'm just going to change this and this and this, and it'll be prettier. Understand there may be other impacts. That was a lot. We made it. 3 minutes to spare. Questions, concerns?
With regard to high-rise buildings, is there a limit to the floors where you can pressurize because you have to take into consideration the state, the door closure, the door closure, the door closure in the type of pressurization? Because there might be a situation where you cannot open the door because of the door closure plus pressure differential. Is there a limit to the number of floors?
So there's not a limit to the number of floors on the sandwich pressurization stuff. There is, however, limitations on sterile pressurization design pressures. So when we design the systems, and it would apply to the stair pressurization or the sandwich pressurization as well. That's why we calculate the differential pressure across barriers. So we measure, I use the stairwell, I'll use that one as the example because it's the same on the floor. When I pressurize the floor or when I pressurize that stair, I have to measure that differential pressure, and it's, I think it's 0.15 if it's not sprinklered, 0.05 inches of water if it is pressurized, or I mean if it is sprinklered. That pressure is evaluated against amount of pressure it creates on a door and the amount of door opening force. So when we commission the system, we measure it as how much force does it open, do I have to push or pull, and we have gauges for that. And it's all calculated based on that pressure differential. So it is measured.
Yeah, because during winter, pressure is
stack effect and yeah.
Summer,
Yeah. So that's all supposed to go into the rational design analysis. That is supposed to be considered. And if you have high pressure differentials, that's either stack effect or temperature created pressure. In a high-rise, have you ever walked into, like, if you walk into the Empire State Building in the winter, when you open the door, there is a wind tunnel blowing past you. That is temperature differential driven airflow. And that can absolutely change. It's supposed to be assessed into the design.
How about buildings higher, say, than 12 floors, very high? Because you cannot just put down, you have to segment the floor, right?
Yeah, so ultimately what happens is in that rational design analysis, there may be mechanical vent louvers that are designed in where it vents air pressure out on floor levels just to maintain pressure differential at the doors. So that all goes into the rational design analysis and the mechanical design. And it could be as you go way up in a building, you get into big high rises, you have to look at stack effect and temperature differential, and they should be designing for it. And that may mean pressure differential louvers. Stairwells, they'll have gravity dampers. So if I kick the fans on, that gravity damper will float and it'll allow any excess pressure out of the stairwell. Usually they try to design for one door open so that I can still maintain my pressure differential. So that design and part of that rational analysis could be assessing if I'm in a really tall building and I have very high temperature differentials from inside to outside, how do we maintain that pressure in the system? And it can be the air handlers have to kick in with higher exhaust rates and all that. So that's why I say when you look at these mechanical systems, when you get into tall buildings, these can be very complex. I may not want to switch that mechanical contractor unless I absolutely have to, because the design takes all that into account, and it is definitely complicated. That answer your question?
Because from my experience, it looks like you will pick up the floors and all like that. You may have to think, otherwise you have to probably modularize the stairways.
Yep. Yeah, so usually in high rises, the stairwells are not usually designed in as part of that airflow solution. There should be mechanical venting. And there will be shafts dedicated to getting the air pressure out. Yeah.
In some instances you might need venting, but you know, as there's the weather, winter to summer, and it happens.
Yeah.
It's like there is a limitation as to the number of floors. After that, you need to.
Yeah, and they'll usually account for that by economizers built into the floor pressurization systems, and they'll be able to reverse the flow and exhaust it out a shaft. So they can change that pressure. They're supposed to be able to change that pressure to account for that.
So there's no limitation that they are not included in the.
It may be a mechanical limitation, and it may come out of that design, but there's not a code one, as far as I know. Any other questions? If anybody does have any additional or want to have